I will talk about the Greenland Ice Sheet and how fast it is melting, why is this important for us, and stuff like that. So I have actually changed the title a little bit. So to start with, I will try to get your attention and figure out or inform you why is this important for you. I mean, Greenland is far away from here. Why should you guys care about Greenland? And next, well, this will of course lead to sea level rise. And so when you talk about sea level rise, now what's going on now? Of course, you have to look back in time. What have happened over the last 1,000 or 10,000 or 20,000 years ago? And then I will shortly talk about why is the sea level rising. There are of course different contributions. There is Greenland which is melting, but also if oceans get warmer and water expand, of course this will cause a sea level rise. And but in this talk, I have 15 minutes, so I will just focus on Greenland and Greenland ice cap. I could give a similar talk for Antarctica, for Alaska, and all the other areas with a lot of ice. The story is more or less the same. And then I will talk about Greenland, what's going on right now, and shortly also try to say something about the future. So, well, first of all, why should you care about this? Why should you care about Greenland and how fast it is melting? This is a map showing Copenhagen. So here you have the situation right now. This is land and ocean distributed as it is right now. And if you increase the global sea level by 90 centimeters, it will look like this. So first of all, if you're living in these coastal areas, you should worry about your house and where you live. According to the most recent IPCC report from 2007, global sea level rise will be somewhere between 18 centimeter and 58 centimeter. Over the last 100 years, sea level rose by 18 centimeters. So this is more or less within the level of what happened over the last 100 years. But the IPCC report, it also says that Greenland is more or less stable, Antarctica is also more or less stable. So they are both, and also Alaska, they are not losing ice. And as you will see in some of my next slides, there are huge changes in Greenland. So the question is, how much reliable is this estimate from IPCC? And also, if we look back in time, here you have changes, or here you have sea level changes in meters over the last 24,000 years ago. And if you look from 20,000 to, let's say, 10,000 or 8,000, then you have a huge sea level rise by 140 meters or so. And this corresponds to a sea level rise per century of 1 or maybe 2 meters. While over the last 5,000-6,000 years, the sea level rise has only been about 10 centimeters or 20 centimeters. So it's much less than what's happened earlier. This is when Scandinavia was covered by ice, and Greenland Ice Sheet was also much larger, and Northern America was covered by ice. This is what you can see here. So the light blue areas are a region covered by ice, by huge ice caps. This is the North Pole, so here you have Greenland, and this is UK, you have Denmark here. So all these regions were covered by ice. So So you can say that you have a lot of water stored on continent rather than on ocean, so most of this ice has melted, and which has caused this huge amount of sea level rise. In general, we can say that melting of Greenland, or let's say ice loss from Greenland, it can be separated into a part called a dynamic ice loss and melting. Dynamic ice loss, it is very difficult to predict, and this is also why there is a huge uncertainty level in the IPCC reports. By melting I mean, if you have a block of ice, you put it on your table, it will melt. If you increase the temperature, it will melt faster. So it is something you can predict. Dynamic ice loss, it's much worse. It's very difficult to predict, and I will show you some results from Greenland. So here again we have Greenland, and next I will focus on the marginal region in southeast Greenland. So this is a glacier, or you can say this is the edge of the ice cap. So this is where the Greenland Ice Sheet ends. Here you have, here and in the background you have the ice cap, and here you have the oceans and the huge icebergs. This wall is about 100 meters tall. Now I will zoom a little bit out, and the helicopter you just saw, it was somewhere located here. Just to give you an idea of the scale. The distance from one side of the mountain to the other are about 5 kilometers, and the lunatics in the background, they are about 25-30 kilometers from the picture is taken. So you can say that here it's ocean, icebergs, and here we have this glacier, and in the background the ice cap. When you think of ice, you should think of ice like honey. It's floating. I mean, if you put it in a table, turn it around, it will flow. And you can actually see the flow lines here. This is how the ice cap is flowing. And it's this change in how fast these glaciers are moving, which is causing this dynamic ice loss. Over the last 30 years, the speed of the glaciers has changed dramatically. And this is just one example. This is Helheim Glacier, and it has changed from about 5 to 15, 16 kilometers per year. So this is how fast the front of the glacier is moving. I could actually, the situation is the same all around Greenland. We see a huge ice, or a huge increase in ice speed for more or less all the glaciers. And next, this is the same picture as you just saw, but from a camera, and this movie is just showing what's going on over one day. So notice the front of the glacier. Remember, it's 5 kilometers wide and about 100 meters tall. And this is our, well, events like this just take 15 minutes, 20 minutes. So we have a huge increase in the velocity of the glaciers, but it doesn't necessarily mean that Greenland is losing mass. I mean, if you have a lot of snow, it could in principle be zero. So how do we measure whether Greenland is losing or gaining ice? One technique is by measuring uplift of the bedground, like, well, maybe down there, where you have some stone and bedrock, and by measuring how fast bedrock is moving up or down, you can actually say whether Greenland is losing or gaining ice. So you can think of the surface like a spring. If you move, or if you put an ice cap, a glacier on the top, it will move down. When you remove it again, it will move up again. So by measuring how fast the bedrock is moving up or down, you can actually measure how fast you are gaining or losing ice. And we have, I think, 65 GPS station bedrocks on bedrock. And this is a typical GPS station. It's running all year, measuring every 30 seconds. This is the GPS antenna. It's driven using solar energy. And once the glaciers move back and thin bedrock starts to move up. So note it's going up here. So this is the location of the GPS stations we have, and they are basically covering the entire ice cap. And we do actually have some problems sometimes where polar bear and other animals try to eat our equipment. And here you have a map of uplift rate. So this is how fast Greenland is moving up. And note, there is no subsidence. Subsidence, I mean going down, it will mean that you are gaining ice. So everywhere you are seeing uplift, which means you are losing ice. And Greenland is actually rising by 3 centimeters every year. And this is average over the last 6-7 years. But over the last 2-3 years, the uplift rate has increased to about, in some places, 5-6 centimeters. So the mountains are getting about this higher every year. Now, another method to estimate the ice loss is by looking at changes in gravity. So here, gravity is, it's not constant. For instance, here where you have this red area, you have huge mountains, so you have more mass in this area. And here, in the oceans, you have less mass. So, and all this can be measured using satellites. The good thing about satellites is that they cover the entire Earth. And if mass is moved from one region to another, it could be a glacier, which thin, or the ice cap would disappear. It could also be an earthquake moving, actually, the Earth. It's something you can measure using these gravity satellites. Next, I will show you results from Greenland over the last about 10 years. And again, they show changes in gravity. So they actually show, or the animation will show you how fast Greenland is melting. So note in southeast Greenland here, we start to see some huge ice loss. Then it's like a disease, it's spreading up along the coast. And well, more or less entire Greenland. So if we wait a couple of years, entire Greenland will be melting or losing ice. Now, to some rates, how fast is Greenland actually losing ice? Using these satellites, we have estimated to about 250 gigaton per year. What does that actually mean? If you place so, this is the land area of Denmark. If you place a wall of 6 meters of water over entire Denmark, the land area of Denmark, that is how much Greenland is losing in terms of ice every year. Well, this is average from 2002 to 12, but over the last couple of years, the number has increased to about 500. So it means a wall of 10-12 meters of water over entire Denmark. That's how fast Greenland is losing ice right now. So now back to the IPC report. It was saying that Greenland is not losing ice, but once you include ice loss from both Greenland, Antarctica, and all the other areas, then it is certainly, or the sea level will certainly be larger than 58 centimeter as estimated by the report. Of course, this is important, and also for the infrastructure what's going on in Greenland is important for us, for infrastructure. So far as I know, for instance, the metro, it can handle up to 70 centimeter of sea level rise. But if it looks like now, it will more likely be a meter. What does that mean? Can't we use the metro anymore, or what? So, of course, this is important when you plan structures which are supposed to last 100 years or more.